Okay, today I'm going to talk about the facade pattern. I recently posted a video about the adapter pattern, and I figured as a good exercise for myself, I just worked through the 23 some design patterns featured in the Gang of Fours book. I'm going to be focusing on a C# implementation, something a little more modern, and trying to make it a little more practical by showing some examples as I talk through it. So the facade pattern it's pretty much what it says in the name. Imagine you're in those old on a old Wild West movie studio, and you see the horse and the cowboy going along the dusty road, and they look up and they see all the buildings, and then when you get behind the camera, you realize that's just it's just the facade of the building is a fancy painted, well-designed front. But when you go to the back, there's this kind of messy chaos behind the facade. And the idea is that from the camera's point of view, all they care about is the front end, so they don't need to build a whole house. Now, in our case, the analogy you've heard before with software probably is that a facade, if you're doing construction, might be the stucco or the panels on the outside, the vinyl siding or whatever, that makes the house look nice. And when you look at the house, you don't really think about the plumbing, or you think about the electrical or the plumbing or the gas or whatever it takes to make the house hum, to make it work. It's just a house. And the idea with code is that in the real world, you're probably more times than not going to inherit some pretty gnarly existing code base that has a lot of moving parts. And if your client, in this case, the client is the code that's consuming other code, if the client has to know about that complicated subsystem, it can take a really long time to develop, and you have to really dig into the weeds and know all of the moving parts, and you may not even be using all of the moving parts. So in code, the idea of a facade is it could be a class or a whole tier or a whole layer, but in this case, we're going to talk about implement it using a class. It could be a class that sort of is a protective shield from all the chaos of the subsystem. So the goal is that the client will consume the facade and make its requests through the facade and get what it needs out of the facade without knowing anything really about the subsystem. So for my example here, with the idea that we're working with something that's existing and something that's a little bit complicated, I went ahead and created a fairly simple example of something complicated. So usually it's going to be much more complicated than what you see here. So I just went ahead and created a console app, and within the main method, it goes ahead and calls this method called execute client, and that's just really to indicate the idea that this code is the client consuming something more complicated. So the metaphor that we're going to use is the idea again of a bag of fruit. So my goal as a client is I want to take a bag and fill it full of fruit, but I want a variety of fruit. In this case, I want some apples and pears, bananas, and oranges. I went ahead and represented those things here under my models folder, and we could take a peek at that. Like in this case, they're very simple classes with a little eat method. And I added a console write line just so that, when we eat the apple, we'll say to the console app, hey, eat an apple. Same thing for banana, same thing for orange, same thing for pear. And one thing you might notice is that it's implementing this iFruit interface. And the interface is really just the eat method. So, okay, back to our main program. So what the code is going to try to do is, first we're going to instantiate this bag of fruit. And in this case, I'm just using a generic list. And it's going to be a list of fruit interface. So that way, the bag doesn't really care about the details of which fruit are in there. It just knows it's fruitable, so to speak. So without a facade, if I wanted to fill my bag full of fruit, you might find that I have to go travel to a banana plantation and harvest some bananas. And then I'll have to go to an apple orchard and pick some apples, and an orange orchard and pick some oranges. and then a pear orchard and pick some pears. And all that logic lives here inside of the services folder. It doesn't have to be a service. It could be anything. It could be factory patterns and services, and could be making calls to RESTful APIs, whatever. But in this case, for my example, I just created these basic little service classes with a pretty straightforward pick method, and pass in the count, and it news up list of apples, and just kind of based on the count, it'll iterate through that count and add some apples to the list, and then return it to the client. And it's pretty much the same here with my banana plantation. I've got my harvest method with a count, and I new up the list, and I loop through that count, and I new up a banana and return that list. Same thing here with the orange orchard, same thing here with the pear orchard. In the real world, this is going to be much more complicated code, probably some business logic with subsystems that have subsystems. You might be really hitting multiple databases, XML files, a variety of data sources that you need to cobble together to create something meaningful for the client to consume and maybe present. But for the purposes of our demonstration, I think this adds enough of a complexity that we can see what the code looks like. So right here, we start with, I'm going to create a list of bananas, or a collection of bananas. And once again, I'm hitting my plantation service, harvesting, I get those bananas, and I'm going to add it to my bag of fruit. In this case, I'm just using the generic list. System collection is generic. I could use an array, I could use a stack, I could use any kind of collection, but in this case, lists are nice and manageable for what I'm doing here. I could even have created a more complicated list wrapper and created a bag of fruit object. So once again, I'm going to go ahead and add some bananas to my bag of fruit, my apples to a bag of fruit, and oranges, and then pears. And as you can see, it takes a good amount of code to fill up my bag of fruit with a variety of fruit types. And once I have that bag of fruit, then I want to go ahead and eat that fruit. And this is just, consider this some client code. It's really a little out of scope of what we're talking about here, but we want to do something that we can present in the console. So what I'm going to do is I'm just going to loop through my bag of fruit. I do it in reverse because I'm going to prompt the user, hey, are you hungry? And if so, they'll click a key. We'll remove that fruit item from the bag of fruit and then go ahead and eat it. And then once we've run out of fruit, we'll just present to the user that there's no fruit left. So this is the client's concern, and that doesn't have to change. The thing that we're trying to solve for is we don't want the client to have to know about the complexity of all the sources for the bag of fruit. Imagine in the real world, you have to get into your truck and travel to the plantations and orchards, and that could be very time consuming, and you might have different qualities of service from each of those locations, and you could really waste a lot of gas. So I'll go ahead and execute this just so we can see that it runs, that it compiles, and I'll go ahead and throw my console app onto the screen. Here I prompt the user, are you hungry? I'll click any key. It'll say, eat a pear, and then it'll prompt you again, eat an orange. And it'll just keep going until I run out of fruit. There we go, no more fruit left. So my program works. It's very simple, but you get the idea. All right, so we want to consolidate this into something simpler. We want to go ahead and create a facade. So I think it would be nice if we go ahead and comment this out. And we'll write the code that we'd like to consume. So imagine I just want to initialize my bag of fruit. And instead of newing it up and going to the different sources like the orchards and the plantations, I want to go ahead and just new up a facade. So I'll call it a fruit stand. Does that make sense? In the real world, if you go to a fruit stand, that's one place you have to go, and you can collect all the different kind of fruits you want, put it in a bag, pay for it, go home. It's much easier. So I'll call this a fruit stand facade. And in that facade, I'd like to go ahead and buy a bag of fruit. And of course, this code doesn't actually exist yet, but this is how I'd like to consume it. And I'll even throw a comment, some pseudocode or comment in here. We know what we're doing. So this amount of code is a lot simpler to wrap your head around than this amount of code. So, all right, the first thing we've got to do is go ahead and create that facade. So we can use the helper right here, and if it doesn't pop up automatically, you can just hit Control period, and you get your refactoring tools. In this case, we'd like to generate a class of fruit stand facade in a new file. And now you got over here. What I'd like to do is put that inside of a facade folder. So I'm going to go ahead and add a folder. I'll just plop that in there. And since I've moved it into a new folder, I want to go ahead and make sure my namespace reflects that. Then I'm going to go ahead and go back to my program. As an aside, I hit Control-Tab as a shortcut to get back to the file I was in. So now I can go ahead and select using demo facade pattern.facade. And that's nice because that'll update my using statements up here. Now the next thing you'll notice is I'm asking for, assuming this facade will have a method. It doesn't exist yet. Now, one thing I love to do is I like to use vars, keeps the code cleaner. But if I'm writing my code backwards, one thing I can do is this, is replace it with the actual type. And then when I use the refactoring tool to generate the method, you'll notice that it will actually add the appropriate signature. So I can go ahead and click that. It'll create the method for me. You'll see the red squiggly went away. And then I'll go ahead and just put this back to var. Keep my code clean. If I mouse over the bag of fruit, you can see its signature. It's returning a list of iFruit. And then I can go ahead and open that method. And we can see it created the method for me. Now I like the internal scope. I'm a fan of keeping the accessors as minimalized as possible. In this case, the program class needs access to this method, so internal is sufficient. I don't really need the constructor in this case. I'm not really doing anything, so I'll go ahead and nix that. And then I'll go back to my program, and I want to move all this complicated code into my facade. And I'll uncomment it. Control KU to uncomment. So now the first thing it's complaining about is it's expecting to return a list of fruit. Well, I'm initializing it here, but I'm not returning it. So let me fix that first. Return bag of fruit. That takes care of that issue. The next thing it's complaining about is this area in the namespace doesn't know how to get to this area of the namespace. So I can just hit Control period and it'll add a using statement for me. There's my demo facade.services. And that pretty much resolves all of that. Now, I'm not using system, it looks like, so I can go ahead and remove and sort my usings. And now my code's a little cleaner. And if I go back to program, I can delete this commented out code. And we'll go ahead and compile my code. And we'll run it and make sure that it does the same thing that we expected it to do before. So I'll go ahead and pull the console up. I'll say, are you hungry? And here it says you eat a pear, and then it asks you again, are you hungry? And so on. It's going to iterate through all of the fruit within the bag until there's no more left, and then the application will exit. So I'm going to go ahead and do that again, but this time I'm going to put a breakpoint and execute the code. Now, I'll go ahead and step through this by hitting F10. And I'm going to mouse over that bag of fruit. And you can see that it has created 9 fruits. And you can see it's been expanded. You've got bananas and apples and oranges and the pear. And then it goes ahead and calls that eat fruit method, which is really just our client doing stuff with the bag of fruit. Once again, that's not really important. So go ahead and continue. And it's going to try to iterate through again in the console. So I'll go ahead and stop debugging. Now, one thing I'd like to do is, since I've refactored it and I've touched the code, well, that's fair game to clean up. So I wonder, can I clean this code up at all? Maybe I can. Maybe I can take this and here. You don't have to do that. Sometimes readability is more important than concise code, but it is a good exercise to see what you can do to reduce the number of lines of code. Some of the strategies, there's some great videos on Pluralsight about functional programming and how to clean up your code. And the neat thing is, the simpler your code gets, the more opportunities it creates to make your code even more simpler. It's sort of a cascading effect. When you're first learning, I think it's great to write a lot of comments. It's a great way to do pseudocode before you write your code. You really don't want to type any code until you know exactly what that code's doing. But once you get good at naming things, it becomes self-documenting. So just looking at this, I have a bag of fruit and I'm going to add some fruit from a new banana plantation service using the method harvest. So it's pretty self-documenting, I think. Once again, this is a very simple example, but the idea here is that we want to go ahead and clean up the code whenever we touch it. And speaking of which, I'm inside of my program.cs. Since I've moved that code to the facade, I've actually simplified my program and its dependencies. The program.cs no longer needs to know about the services. And that's really the key here. That's what this facade pattern is all about, is making the client agnostic of that subsystem. And in this case, our service classes is the subsystem. So I'll go ahead and do removing and sort. And now my code is a lot cleaner. So hopefully you can see that the facade pattern is really all about reducing complexity. And once you've reduced the complexity at that top tier, you can start to implement cleaner design patterns and focus on presentation and not so much on the complexity of how to get the stuff to the presentation. So, all right, I hope that helps.